we take the process of heat transfer through conduction. Conduction is a process in which heat will be transferred without the motion of the material. For example, we consider a rod. We know that this rod is made up of so many molecules. We are not going in detail about how these are arranged, all these things. And when you heat at one end, we can feel the heat at this end or the rise in temperature at this end after some time. And this is due to the conduction. How this occurs means when you heat this, initially the molecules which are present at this position, they take the heat, they start vibrating. And because of these vibrations, they will affect the next particles. They transfer heat to the next particle. Again, because of the vibrations, the heat will be transferred to next particles. Like this, the conduction will occur. That is, heat will flow from one end to another end. And to occur this conduction, suppose if this is hotter one, this is colder one, then only the conduction will occur. That means always heat flows from high temperature to low temperature. For example, we consider I have taken a rod. At this end I have taken ice. And here I have taken some furnace or some heat. Now in this case, in which direction heat will flow? Yes, heat will flow from this portion to this portion. That means from higher temperature to lower temperature. To define the conduction, a uniform rod of length d having area of cross section A, as I was saying in the figure. If this end is at temperature theta 1 and this end is at temperature theta 2, if the temperature of this end is more compared to the temperature of this end, that is when this is kept at higher temperature, then the heat will flow from one end to another end. Now the amount of heat that flow through this rod, that we consider it is Q, this is directly proportional to the temperature difference. That means if the temperature difference is more amount of heat will flow. The amount of heat flow is directly proportional to the temperature difference of these two ends. And it is directly proportional to area of cross section. If the area of cross section is more, that means if it is having more area, more amount of heat will flow. It is having less area, less amount of heat will flow. For example, if we consider a canal, if the canal is having more area, more amount of water will flow. If the canal is having narrow area, less amount of water will flow. And it is directly proportional to the time taken. That is, if it is kept for longer time, more amount of heat will flow. If it is kept for less amount of heat will flow. And it is inversely proportional to the distance or the length of the rod. Why? Because if the length is increasing, the resistivity will increase, so that the amount of heat flow will decrease. Combining all these equations, we get Q proportional to theta 1 minus theta 2 into TA divided by D. From this equation, I can write the amount of heat flow Q proportional to theta 2 minus theta 1. I am taking this is d theta. This can be written as A into T into d theta by D, or the rate of heat flow. This can be written as heat by time. This proportional to A into d theta by D. And this can be written as Q by T equivalent to some constant K. I am removing this proportionality and writing this proportional constant K, A into d theta by D. This K is called as the coefficient of thermal conductivity or the conductivity of the rod. And in this case, suppose if I consider A equivalent to 1 meter square, d theta equivalent to 1 degree Celsius, D equivalent to 1 meter, and time t equivalent to 1 second. If I substitute all this, then I get K equivalent to Q joule. That means the coefficient of thermal conductivity is defined as the amount of heat flow through a rod having 1 meter square cross-sectional area, 1 meter length, when the ends are at a temperature difference 1 degree Celsius in 1 second time. And the units of K, from this equation we can write K equivalent to QD by TA into d theta. And if I substitute all the units, Q is joule, D is meter, T is second, A is meter square, d theta is degree Celsius or Kelvin. Or this is equivalent to watt per meter Kelvin. This is the unit for coefficient of thermal conductivity.